Hi guys, so let's solve this question. It says we have to design a label and it has red circles and blue circles and the total height is 10 centimeters. So the total height given to us is 10 centimeters. The minimum diameter we can have for any circle is 2. And the bottom always needs to be red. All right, so if we start with the radius of 1 centimeter, so the diameter is going to be 2 centimeters, right? So that means out of 10 we have used 2, remaining is 8. So the maximum radius we can have is 4, right? And it could be either ways. Red can be 4 and then your blue is going to be 1 centimeter of radius, and if your blue is 4, red is going to be 1 centimeters. Use a table to investigate the area of the red circle and its radius as the radius increases. So I have created a table here. So we have just found that we can have radius of 2, diameter of 2, 4, 6 and maximum 8. That means the radius can be 1 for red circle, radius can be 2, 3 or 4, and the maximum you can get is 4. Right? Area is pi r square. All right, we're going to plug those values in, and in this case, just to keep it simple, we are going to use pi as 3. Right, so it is going to be 3 times r square is 1, which will give us 3. 2 square is going to give us 2 times 2 is 4 times 3 is 12. 3 times 3 square is 9 times 3 is 27, and 3 times 4 square is 4 times 4 is 16. 16 times 3 is 48. All right, and these are the areas of the circle, the red circle. Now, what we have to do is investigate as the area increases. So what we need to investigate is what's happening here. All right, so when we are investigating, the first thing we can find is the area of, the equation of this thing that we are investigating. So equation for this one is not that tricky. Equation of, because r is square, is a quadratic, and quadratics are graphed as parabola. All right, you can graph it if you want, but today we are focusing only on the table. So this one is pretty easy. This one gives us 3 and then radius square is happening, and that radius is the x. So if your area is your y-axis and radius is your x-axis, it is 3x squared, right? 3 again, x square gives you the y value, 3x square gives you that, 3x square gives you that. So the equation is y is equals to 3x square. Right, so this one was not that tricky. Another way of finding the equation is, if you can't see that here, is you find the difference. So you will find the difference here. So 12 take away 3 is 9. Let me use a different color just so you can see the difference of what I'm doing. 27 take away 12 is 15, and 48 take away 27 is, what is that, 21, right? Always in the quadratic, the second time when you find the difference, they are same. So 15 take away 9 is 6, and 21 take away 15 is also 6. So second time when you are doing the difference, they are equal. All right, and that means it's a quadratic. So if you remember the standard form, y is equals to ax square plus bx plus c. All right, from there we can have a, b and c values, and it will create our quadratic equation, right? So a, b and c. A is always half of the second difference. All right, so that is going to be 6 over 2, which is 3. All right, c is your y-intercept. Right, c is your y-intercept. That means your x value is 0 here. right? So when x is 0, what is the y value? So here when radius is 0, the area is also 0 in this case, right? So your c value is 0, right? Because that is your y-intercept. Now b value is what you have to find by substituting certain things. So in the equation we have 3x squared plus, we still don't know what b is, and we know the c in this case is 0, right? Now we have so many of x's and y's values, right? Not here though, this one's, because we are not using the diameter as such. So we have these values, we can plug in any of those. So let us suppose we are taking 1 and 3. So if x is 1, y is 3. So we will have 3 is equals to 3, 1 square plus b, 1 plus 0. 3 is equals to 3 plus b, because the next is 0. So in this case, b is 0. So b is 0. Now if you put the values back in here, you will end up getting y is equals to a is 3, x squared, b is 0, so that becomes 0, c is 0. So that is your final answer, which we already did. So if you can't see it straight away in the table, you can calculate it using this method. All right, now let's see what the second question is. So second says, state the equation of the graph that represents the total area of red circle and blue circle, so the total area of both, as the radius changes. So again, we'll have to create a new table to do that. And in the last one, they ask general equation of total area of two circles with the sum of the radius. So that's going to be interesting. So the second bit is, so the second part here is the radius of red circle. So we have recently done that. So radius is 1, 2, 3, 4, and these were the areas. So if I put that down straight away, 1, 2, 3, 4, that was 3, 12, 27, and 48. All right, so we also know that if radius of red circle is 1, the radius of blue circle is going to be 4. If radius of, so we have two circles like that, right? And the total distance is 10. So if the radius of 1 is 2, so next bit, the total is 4 that is used. So it's going to be 6 left. So that means the radius is 3. And then if it is radius is 3 for red circle, it's going to be 2 and then 1, right? We already have calculated the areas of these. So when radius was 4, the area was 48. When radius was 3, the area was 27. 2 was 12. 1 was 3. I hope this is making sense. Yeah. Now next is your addition. So you have to add the total areas. So let me highlight it so we don't get confused. We are adding this column with this column because these are the two areas, right? So that is going to be 48 plus 3 is 51. 12 plus 27 is 39. 27 plus 12 is 39. And 48 plus 3 is 51 again. All right. So now we have the radius or our x values, and we have the total area as well. Right? Change of the radiuses, we can take any one of it because it is kind of the same 1, 2, 3, 4. Now we need to calculate the equation for this as well. So let me write that separately just so to get rid of any confusions that might happen. So we are using these two things, right? So we have these 4 values, and now we have to find out something. So from here now, let's find the differences that we were doing. So 39 take away 51 is minus 12. 39 take away 39 is 0, and 51 take away 39 is 12. That's the first level of difference. The next one, 12 take away 0 is 12. 0 take away minus 12 is 12 again, right? And these two should be same. Now we have to write the standard form. Y is equals to square plus yx, plus bx plus c. So we have to now find a, b, and c. A is half of the final value, so that is 12 over 2, which is 6. C is when the radius here, in this case, when it is 0. So when the radius of red one is 0, now because we are comparing the two, that means if red is 0, the radius of blue one was 5, because the total height is 10. We can still have a radius of 5 centimeters. And if the radius is 5, that area is going, so here that is 0, but 5 is going to give me 3 times 5 square, which is 75. So the total area is going to be 75, right? So our C value is 75. Now B is equals to, again we have to substitute the values. So this is now equals to 6x square plus B we don't know yet, whereas C is 75. Now we can substitute any of the values, right? Let's start with the 1, that's easy. So 51 is equals to 6 1 square plus B1 75. 51 is equals to 6 plus B plus 75. So that is now going to be 51 take away 6 take away 75 is equals to B. So now let's do the calculation. 51 take away 6, or we can do 75 plus 6 is 81. 51 take away 81 is minus 30. So B is minus 30. Right, minus 30. So your equation, your final equation is y is equals to 6x square minus 30x plus 75. Right, so now if we want to factorize it further, we can do that. Whatever we want to do with the equation we can do, but for now I'm going to just stop it there. We can do factorizing or other bits in a different video, because that's not a part of this question right now. Now the third bit is, let's read the third part. The general equation of the total area of two circles where sum of the radii is n centimeters. So now we have to find the sum of the radii as well, right? And sum of the radii, if it is n, let's see what we can do. So let's do it. So we are doing the third one now. So we know that sum of the radii is equals to n, right? So if radius of one circle, any red circle, is equals to r, radius of blue circle is equals to n minus r, right? Because the sum is n. So if we find the area, because they are asking us to find the area, they are asking us to find the general equation of the total area of the two circles, right? So the total area is equals to 3 pi is 3, pi r square. R is n square for the, no. So 3 r square for the red circle plus 3 n minus r square for the blue circle. That is the total. So we can take 3 common, r square plus n minus r whole square. Yep. So now we just need to expand r square plus. When you expand this, n minus r whole square, if you know the identity that it will make n square minus 2nr plus r square, amazing. If you don't know that identity, you can still do the expansion. N minus n is n square, n minus r is minus nr, minus nr plus r square. So that's again going to give you the same thing that the identity gave you, right? So that is giving us n square minus 2nr plus r square. 3. R and r is 2r square minus 2nr plus n square. And that should be the answer. If you want, you can expand it further, but I would say, yeah, that is the answer we might be expecting, or 6r square minus 6nr plus 3n square. Both of these answers are fine. Great, that was an interesting question. It was a 2018 level 1 maths question. So yeah, cool. Have a good day.